everyone. In this task, we are here to derive a binomial identity involving a summation of binomial coefficient with even upper indices. Specifically, we aim to prove the closed form expression for the sum of quantity of 2 taken 2 plus quantity of 4 taken 2 plus quantity of 6 taken 2 plus ellipsis quantity of 2n taken 2 is equal to n quantity of n plus 1 quantity of 4n plus 1 all over 4 n is greater than or equal to 2. Hint for m is greater than or equal to 2. Quantity of 2m taken 2 is equal to 2, and quantity of m taken 2 plus m squared. Now we are here to prove that m is equal to 1 to n of the binomial coefficient 2m taken 2. So for our next step, we use the binomial coefficient. We get quantity of 2m factorial all over 2 factorial quantity of 2m minus 2 factorial. So for any positive integer of m, any integer k. So by cancelling out either m or n minus m factorial in the right side. So we have 2m quantity of 2m minus 1 quantity of 2m minus 2 factorial all over 2 times 1 to quantity of 2m minus 2 factorial. Now, since the same quantity 2m minus 2 factorial appears in numerator and denominator, we cancel them and we get 2m quantity of 2m minus 1 all over 2. And for our next step, we cancel the 2 over 2 from the numerator, and the denominator will get m quantity of 2m minus 1. And for now, we rewrite the sum and expand the inside, so we get quantity of 2m squared minus m.
So the next step, we will use the rule of summation number 3. So summation of 2m squared minus m from m is equal to 1 to n will become summation of 2m squared from m is equal to 1 to n minus summation of m from m is equal to 1 to n. So basically, we separate 2m squared and m by using the rule of summation number 3. After that, we can take the constant, which is 2, out of the summation because constants can be factored out. After that, we can take the constant, which is 2, out of the summation because constants can be factored out. So after that, we're ready to use known summation formulas for summation m squared and summation m. For m squared, we will use the formula for the sum of the square of the first natural numbers, which is n times the quantity of n plus 1 times 2n plus 1 all over 6. And for m, we will use the formula for the sum of the first natural numbers, which is n times the quantity of n plus 1 all over 2. For m squared, we will use the formula for the sum of the square of the first natural numbers, which is n times the quantity of n plus 1 times 2n plus 1 all over 6. And for m, we will use the formula for the sum of the first natural numbers, which is n times the quantity of n plus 1 all over 2. We will substitute the formulas into our expression. So it will become 2 times n times the quantity of n plus 1 times the quantity of 2n plus 1 all over 6 minus n times the quantity of n plus 1 all over 2. After that, we will multiply 2 to the first term and just copy the second term. And it will become 2n times the quantity of n plus 1 times the quantity of 2n plus 1 all over 6 minus n times the quantity of n plus 1 all over 2. So for the next step, we need to combine the first and second term. So to combine, both terms must have the same denominator. So to make that possible, we need to find the least common denominator of 6 and 2. So the least common denominator of 6 and 2 is basically 6. So it will become 2n times the quantity of n plus 1 times the quantity of 2n plus 1 minus 3n times the quantity of n plus 1 all over 6. So 3 appears because we multiply numerator and denominator of the second term by 3. Because on our previous step, we find the least common denominator of 6 and 2. As you can see, there are common factors which are n times the quantity of n plus 1. So basically, we can factor them out. So it will become n times the quantity of n plus 1 times 2 times the quantity of 2n plus 1 minus 3 all over 6. Next, we will simplify the expression inside the bracket. To simplify the expression inside the bracket, we will use or apply the distributive property. So we multiply 2 to each term inside the parentheses. So 2 times 2n gives us 4n, and 2 times 1 gives us 2. So the expression becomes 4n plus 2 minus 3. So we can simplify it further. So 4n plus 2 minus 3 will become 4n minus 1, since 2 minus 3 is equal to negative 1. So our final answer is n times the quantity of n plus 1 times the quantity of 4n minus 1 all over 6. Hence, the formula holds true for m is greater than or equal to 2.